Hello, I welcome you all to this channel MSK Learnium. Now in this video we will see the Lagrange's mean value theorem. So in previous video we discussed the Rolle's theorem and then we see that how to verify the given function, that whether it is satisfied the Rolle's theorem or not with working example. So now we will see the Lagrange's mean values theorem. So here that let f of x be a function such that it is a continuous in closed interval a comma b and differentiable in open interval a comma b, then there exists at least one point c in open interval a b such that f that dash of c is equal to f of b minus f of a by b minus a. Means any function is given to you and then you have to verify that with means Lagrange's mean value theorem you have to verify. So first of all you have to see whether the given function is continuous in closed interval and differentiable in open interval. Once these two conditions is satisfied that function, then we will see that one point we have to take, that c, and then we have to find that whether the f dash of c is equal to f of b minus f of a by b minus a, right, where a and b are the some values, right. So now we will see one working example and then we impose these conditions. So here we go, that verify the Lagrange's mean values theorem, right, for f of x is equal to x cube minus x square minus 5x plus 3 in closed interval 0 comma 4. So here we have a one function is given, that is the polynomial function, and that these values is given and the closed interval 0 4, right. So let's say 0 is a and b is the 4, right. So as this function f of x is the polynomial, so it must be differentiable as well as continuous in open interval and the closed interval, right. So now what we think to say that as it is the two condition is satisfied because of this polynomial function, so we need to consider that there is a point c which on open interval such that f dash of c is equal to f of b minus f of a by b minus a, right. So here we go, that we can say solution f of x is equal to x cube minus x squared minus 5x plus 3, right. Then we can say it is a polynomial function, that f of x is a polynomial function, right, polynomial function, right, in x. So then we can say therefore it is continuous, and derivable, right, for every point of x, for every value of x, right. For every values of x means what, the values 0 and 4 is given, right. So now, so here hence by Lagrange's mean value theorem, right, by Lagrange's mean values theorem we can say there is a point c which exists in open interval 0 comma 4, right. Mean value theorem, there exists a point c in closed interval 0 comma 4, right, that is open interval, sorry, in open interval 0 comma 4. So therefore that we can say f dash of c is equal to f of b minus f of a upon b minus a, right. Now, so first of all what we need to do, that f of c we have to find. So f of c is nothing but whatever the f of x is given, right. So f of x is given, that is x cube minus x squared minus 5x plus 3, right. So first of all what I'll do, that we'll find out the f dash of c, right. So f of c is equal to we can see that is c cube minus c square minus 5c plus 3, right? So we can differentiate, that is f dash of c is equal to what? C cube differentiation is 3c square, c square differentiation is 2c, and 5c differentiation is minus 5 plus 3 is 0, right? So we got that f dash of c, right? Now we can say that f dash of c is equal to what? F of b minus f of a upon b minus a, right? So b is what? Where b is equal to 4 and a is equal to 0, right? It is given, the values is given 0 comma 4 in that particular questions, right? So f of b means what? F of 4 we have to find. So f of 4 means f of x, we will see that, which is 4 cube minus 4 square minus 5 into 4 plus 3. Is it or not? Right. So this is what? 64. Here we can write that it's better. 64 minus 16 minus 20 plus 3. So this is how much? That is 31, right? Similarly, we can go for the f of b is there, so we can find f of a, right? F of a means 0, right? So that is 0 cube minus 0 square minus 5 into 0 plus 3, which is nothing but the 3 only, right? Now a b minus a is equal to 4, right? And b minus a is equal to 4 minus 0. So now we can say f dash of c is equal to what? F dash of c is equal to this, we have substituted, and f dash of c is this one. So we can say 3c square minus 2c minus 5. So here we go, 3c square minus 2c minus 5, right, is equal to f of b. F of b is what? 31, and f of 0 is 3 by 4, right? So here we can say that is 3c square minus 2c minus 5 is equal to 28 by 4 is 7. So while we bring it this side, so it will be minus 7 minus 7 minus 5 is minus 12. So this will be quadratic equation, 3c square minus 2c minus 12 is equal to 0. We have to find out the c value right now, and then we need to see that whether it is exist or not, right? So here we can say therefore that c is equal to what? Simply you need to find out the root of this quadratic equation, that is minus b plus minus root d by 2a, right? So minus b is what? Minus minus 2, so 2 plus minus root d means b square minus 4ac. So b is minus 2, that is 4 minus 4ac. 4 is 4 only, a is 3, and c is minus 12, right? So minus minus plus, that we can say 4 3s are 12, and 12 12s are 144, right, by 2a. So 2 and a is 3, right? So this is 2 into 3, sorry, that is, so c is equal to what? C is equal to, you can say 2 plus minus 148, right? So root over of 148 by 6, right? So on simplification we'll get the 1 plus minus root over of 37 by 3. All right, now so we can see that c 1 plus c is equal to 1 plus root over of 37 by 3 is lies in an open interval 0 comma 4, right? So c is equal to 1 plus root over of 37.3 is lies in open interval 0 comma 4, right? So hence thus the Lagrange's mean value theorem, Lagrange's mean value theorem, Lagrange's mean values theorem verified for the given function, right? That is, for the given function is what? Fx is equal to x cube minus 3x square, right, minus 5c plus 3. Is it or not? At 0 comma 4. Thank you.